I'm Tahir, Abbas. I will be conducting today's discussion session. Today's discussion session is related to computer-aided design softwares and their future, or how they will behave in the future. And you may know all of these or some of these, or you have used any of these. So I will, and the professor has explained very briefly how the input may change, like gesture recognition, and changes propagate automatically, and describing design with minimal input. So I want you to just think about the question one, how the type of input may be used, and there is a picture. Do you know this type? Sounds.
This is very soft, so you can use your own.
Actually, my speaker is good, but it's the version is not too
Right now we interact with computers in a very unnatural sort of 2D way. And we're trying to create these 3D objects using a variety of 2D tools. And it doesn't feel natural, it doesn't feel normal the way you should do things. So we started playing around with the idea and using a few of the things that are available out there, such as the Leap Motion and Siemens NX, which is what we used to design the rocket. And we wrote some code to integrate the two. And we started off with what you see here, which is a wireframe of the Merlin rocket engine. And what I can do is I'm going to grab it, and I can rotate it in multiple dimensions. And then what I can do is I can put another hand in there, and I can zoom. Oh, I can zoom in and out on the wireframe. And then I can also translate it. So I can move it around the screen, and then zoom and translate. And this is what we started off with a few months ago. And then you can also spin it, and then catch it. So this is kind of a fun way to interface with what is really a very complex model. Now we'll go from this to what we're able to advance to a few weeks after the wireframe, which is to actually use a full 3D CAD model of the engine. So here what you're seeing is the actual interaction with the CAD software manipulating the real 3D model of the Merlin engine just using hand gestures. If you could just go in there and do what you need to do, just understanding the fundamentals of how the thing should work, as opposed to figure out how to make the computer make it work, then you can achieve a lot more in a lot short period of time. So then we went to a 3D projection. We started off with the kind of 3D projection that you're familiar with in the movies.
So now what you think about the gesture recognition, and is it implementable or not? And what will be its effects on productivity and how long will it take? Actually, that video is about 3 years old. They have implemented it like 3 or 3.5 years ago. So what are your views about using that thing in actual environments?
I think if you heavily depend on the gestures, it can be really tiring for the designer.
Yes, but maybe it is because we are trained in the mouse and keyboard, not in the gestures.
But even so, I think that there are much more movements.
I think so. I think about the precision of the gesture is still like kind of in doubt right now. You have to develop about the precision and stuff.
I think if we need to change the or shift the industry towards such techniques, we have to force them to leave other CAD system, and so that I think there is some stereotypes like it has been 60 years we are using the CAD system, so we are really handy with our mouses and etc. So, but if as an experiment in an organization for 1 month or 2 months, we don't let them use traditional. This way, this is implemented.
Well, I think that every industry puts a lot of money and time in training its engineers. So maybe that is the problem, because engineers are more productive with mouse and keyboard, not with the gestures. Maybe that platform work better for artists who are using 3D tools like Maya 3D, etc. for animations and movies. Any other comments?
About any gesture, I think there's not a goal, because there are many functions in the system, so we need many hand gesture, so I think it's very limited.
Does it actually have to be hand gestures? Since we can, I think the main idea is to view, as Alan said, about the 3D viewing, 3D designing, not from a 2D drawing, right? So maybe it's possible using a different kind of implementation.
Like
besides hand gestures.
maybe the clay model. Have you ever tried to model clay by the hand? Then
Yeah.
computer automatically converts it to something. Maybe that is okay. Any other comments?
Maybe something like a remote control.
Yeah. There was a comment under this video. You cannot see the red. Sorry. A 3D modeler who has 9 years of experience, he said the same thing, that interface looks cool, but there will be problem with your wrist and shoulders and arms, because you cannot rest them because you are always moving them. And the important point, he said that what is important is you can make it, not how you display it, because clients need the model and product, not the process. So that was the thing. Now let's move to the, I think it is covered in this thing is also covered in this question, that how we can, no, this was shown by professor, but these two are combined. How can we work with minimum details for our design system? I will show you an example. You can also use it on your own PC with.
Think about all the stuff you can do on your phone. Man on the moon. Use your phone to draw a moon. Exactly. Your phone can help you do anything fast. It just can't help you draw something simple fast. Think about it. If you're not a designer and you want to make a quick party flyer, where do you even go for that? You'd probably have to download some app or buy a design program. So a few of us at Google created AutoDraw. It's a drawing tool for the rest of us. AutoDraw pairs the magic of machine learning with drawings from talented artists to help you draw stuff fast. Say you want to make your friend a poster for her birthday. You'd go to the AutoDraw site from your
You can just go to the AutoDraw site, like, oh.
Press the, yeah.
It usually works, but
Press the middle.
yeah.
Middle.
Oh.
So if we want to make something, like we'll make a topic. Oh, it's a so yeah, you can get this. So
Try again the talking.
actually, I did the document, but I okay.
So if the drawings are presets, why not just use like a keyword search or something?
Yeah, you're right, but you can. I think I did not did something good, but let's see. Maybe make something like a helicopter. But it is showing because
You need another slate for
yeah, I should see.
helicopter. Tail light. You know.
Yeah.
Very clever. Then can you modify this after? No?
No, I cannot. It is one try.
One. Image search. Sketch-based image search.
So it was an example of minimal input. So here is the question. Same, minimal input and details worked out in the system. So what do you think about such an application for the CAD? Like you just define some minimum output, for example, for a car or for a small mechanical object, then the system gives you some options. So what are your views? Maybe if it is workable, then less work would be required, but if it is not workable, then because of it does not allow you to be independent in the design. What are your views?
I think it's also workable if there is a very intuitive like editing feature to the already designed presets.
Actually, basically for the Google's R tool, there is an AI algorithm working behind. So maybe for the 3D, the algorithm of AI is maybe difficult or requires more computation. Maybe that is limiting the software implementers.
For that, does the AI algorithm create the drawing, or does it match it with a database of drawings?
Maybe the database, you're right. I'm not sure whether. It can create, but it can also match.
I think it can work because, like, as you show us, you don't have to precisely draw, and I think we can use that, like, in the future. It may be applied to the smartphone, or as our lecturer said that the hand, like the touch screen, is not that precise, but by this way it may be like possible.
I think it's to some extent it will give you the object which we want to manufacture, but since we are going to physically make the product, so dimensions matter and lot of work for the machining is required. So, but this is a step towards minimum input.
You're saying that it is workable when the CAD model is editable, right?
Yes.
Yeah, it should work like this, but we do not know yet. Any other? There is an example of minimal input is generative design. It is basically topology optimization. You want to show
The world of design and manufacturing is experiencing rapid change, driven by the maturity of industrial additive technologies and aided by AI algorithms. Take the design of a performance automobile, already lightened and strengthened with advanced material alloys and modern manufacturing techniques. Let's see how we can further improve just one subassembly of the system using generative design technologies in Fusion 360. The base component of this pedal is currently comprised of 87 different components, 13 of which are machined or made from sheet metal. To optimize this, we'll begin by pulling off important geometry to be preserved throughout the design exploration. This can be done in Fusion 360 in a number of different ways, but we'll use the patchwork space to replicate existing geometry. Once done, it's automatically sent to the generative design setup, where we'll further describe the problem. Starting by defining those preserved obstacle regions, which will ensure form and fit throughout the generated geometry, while optimizing strength in relation to factor of safety, using loading conditions in conjunction to manufacturing limitations, such as these additive-driven overhang angles at minimum thickness definitions. And of course, we can't forget to define the additive-specific materials. From there, begin generating the outcomes. And even though generating tens or hundreds of potential solutions is processor-intensive, it will go unnoticed by the user, as it is solved in the cloud. This allows the designer to stay productive and will ensure those results are available faster. We have 16 unique solutions available, and it's up to us to find the design that best fits our needs. Luckily, there are numerous ways to sort, view, and compare. Filters will help remove any solutions heavier than the original, and the winner will be exported to a VREP body, ready for post-generative steps. First and foremost, we'll verify that the pedal movements are unimpeded by the new shape, and once confirmed, we'll take advantage of the collaborative environment Fusion 360 opens up by enlisting a team member to help in the CAM workspace. There they'll add locating features, address work holding, and create the toolpaths to meet rigorous tolerances required in such a design. While that's being done, further finite element analyses can be run in context to the assembly, and additional failure criteria and loading conditions can be checked. In the end, the generatively designed replacement, one that will have taken a designer months to realize, will be 15% lighter, stiffer, and stronger. But perhaps most important, there are 86 fewer parts, saving on labor, purchasing, and Q&A, just to name a few. And it wouldn't have been possible without generative design in Fusion 360.
So, this is where we are now, computing in the cloud and having collaborators and making a design. Do you have any comments about this video?
How I effective is it right now?
Actually, it is only available for industrial use, not paid use. So for academics, it is not allowed. So I did not try it myself, so I cannot. And thank you for listening.